Hi, I'm Bridget Murtaugh, a program manager on the .NET team here at Microsoft. Welcome back to .NET for Apache Spark 101, where we explore the exciting world of big data analytics within the .NET ecosystem. In this video, we're going to be looking at batch processing with .NET for Apache Spark. So what is batch processing, or what is batch data? Batch processing means that we're working with data that's already been stored. So for instance, we could be performing log processing, which means analyzing user logs from maybe a website or a server of some sort. And we could gain insights such as which pages are most popular to our users, or what type of commands do they typically run. Another application for batch processing is data warehousing, such as analyzing a mass amount of data that we have stored somewhere in Azure Storage. In this example that we'll go over in this video, we're going to be looking at some GitHub's projects data. So we have a CSV file that has a list of various GitHub projects, including their name, the URL, who created it, and the number of times they've been forked from. In our case, we want to do some data prep, and then we want to know, on average, how many forks does each language have. You can see that that column H there represents the number of times each project has been forked. So here I'm opening up a C# console application that I've already created, and it's called Batch Spark app. I've already installed the Microsoft Spark NuGet package, so I'll be able to have access to all of that great .NET for Apache Spark functionality. At the top, I need to make sure that I'm importing over the Microsoft Spark SQL and SQL functions into this program, since I'm going to be doing batch data processing, and that relies on Spark SQL. So once we actually have the Spark SQL and Spark SQL functions imported over, we can go ahead and start off by creating a Spark session. So we're going to create a Spark session at the beginning of any .NET for Apache Spark application that we write, because the Spark session is going to be in charge of creating tasks and dividing our information over those worker nodes, or those executors. So with my Spark session, I'm just calling it Spark. I go ahead and build it, and I can give my app the name My First Batch App. Pretty suitable for creating my first .NET for Apache Spark batch application. And then I just call getterCreate, and my Spark session has been successfully created. So now that I have access to all of the .NET for Apache Spark functionality, I can go ahead and start creating a data frame. So a data frame is what we want to use to read in any sort of structured data. So in our case, we're going to be using a data frame to store the project's CSV file that I had mentioned earlier. And we can go ahead and define a schema for our data, which is going to be what type of values are in each column. So for instance, in our schema here, we can see that I have values for the ID of my project, the name of the project, when it was created, how many times it's been forked from, and when it was last updated. And I also have a type for each of those column names. Now that I've defined a schema, I can go ahead and determine what type of file I want to read in. Since my data is stored in a CSV, or comma-separated values file, I'm going to choose this .csv method and call in the name of my file, which is projects_smaller.csv. Great, so now I've read in my input file, and let's just say I want to see how it looks. I can go ahead and call my data frame object, and then the show method, which is going to print my data frame to the screen. I'll start off with a fresh terminal window here, and then I'm going to navigate into my Batch Spark apps directory. Now that I've done that, I can build my app. The build succeeded, and then I want to run the Spark submit command, which is actually going to run my program. So my program successfully ran, and we can see my output here. So while the output does have all the information in columns, we can see it's a little bit messy. Some of the columns are overlapping, and there's a lot of null data. So we want to do something called data prep, or data preparation, which is cleaning up our file so that we can better analyze it and make sure we don't accidentally try to analyze some sort of null columns or values. So I'm going to start off by dropping any rows that have NA values, or null values. And I can do that by calling dataframe NA functions. With dataframe NA functions, I can determine how I want to deal with missing values in my data. So for instance, if later I know I'm going to want to perform some sort of math or other calculations, I might want to just get rid of any rows that have NA values to avoid any sort of errors in my code. So in my case, I'm going to say that I'm dropping any, which means I'm dropping any rows that have some sort of missing values in them. And now that I've cleaned up and removed NA values, I also want to remove some unnecessary columns from my data, since we saw our data frame was kind of long and overlapping with itself. So with that, I'm still going to use my cleaned projects data frame, and I'm going to call the drop method. And I'm passing to the drop method the names of the columns that I want to get rid of, or that I want to drop. And this will ensure that my data frame is more concise and only contains the information that I need. I don't think I'll need the ID, owner ID, or URL of my project for my overall goal for my analytics. And as one final step, it's always good practice to call spark.stop to ensure that our program can stop running successfully once we've completed all of our execution. So I'm going to open up my command prompt again and build my project, since I've written some new code and made some changes to it. And then I can call Spark submit again. And now we can see with our output from here, we have a much cleaner data frame. There aren't any null values like there were above, and there aren't too many extra columns. The data frame isn't overlapping with itself. So now that we've done some data prep and cleaned up our data, we can actually start doing the calculation we wanted, which was to see the average number of times each language has been forked. So in order to do that, since we want to find something for each language, it would make sense to group our data by each language. So I'm going to create a new data frame here when I'm performing a new calculation, and I'm going to call the group by method. And with group by, I can determine which column of my data frame I want to group my information by. So in my case, it's language. And then the .agg stands for the aggregate method, and that means that I'm applying a method to each group that I've grouped by. So in my case, I wanted to find the average number of times each language has been forked, so I'm going to pass the average method in the aggregate method. Okay, so now that I've successfully performed the calculation that I wanted to, I can go ahead and perform one more step so that I can see my data a little bit more cleanly. I'm going to call the data frame that I did the grouping and the aggregation with, and specifically call order by and then descending, so that I can get the most forked from languages at the top, since I'm most interested in seeing those first. All right, and then I also want to call show so that I can actually view my output. It's always a good method to call. So I'm going to open up my command prompt again and rebuild my app. I can see that it succeeded, and so now I can Spark submit to run my application once more. And there we go. We can see that we have the average number of times each language has been forked, and it's in descending order. So the top forked languages are at the top. Thanks for joining me in this video, where we created and ran our very first batch processing app using .NET for Apache Spark. Be sure to check out the other 101 videos in this series to learn even more exciting functionality that we can create using big data analytics in the .NET ecosystem.